Hi everyone, we will start in just a second. We're just giving some people time to log in and then we'll get started. I guess in the meantime, welcome to all of you and thank you for joining me today. We're going to talk about getting started with RAG chatbots. And maybe just before we start, a little bit about myself or proof that I'm not an AI chatbot. So I've worked for Aporia for about 3 years. I'm the director of AI at Aporia. I come from a background of software engineering and cybersecurity. I'm married. I love to travel, play basketball in my free time. I love snowboarding. And yeah, pretty outgoing when I'm not in front of a keyboard, which is like 95% of the time. All right, so what we're going to talk about today is the goal for today is to give you all the resources you need to get started with RAG. So ideally, by the end of this webinar or talk, you feel comfortable enough opening up your laptop and start building your very first RAG chatbot. And just out of curiosity, I don't know how this really works, but I'm going to start a poll. Let's see if I can get it started. Was going to ask, let's see if that works, if you guys can see it. What's your background? So how many of you have heard the term RAG before today, and how many of you have actually built a RAG system before today? All right, cool. So I see about like everyone have heard the term RAG, which is, I think that's good. I did this same type of talk about 6 months ago, and it was like 30% who heard the term RAG, and now it's 100%, so that's good to see. And about 30% have actually built a RAG system before today, so that's cool. So for the other 70% that haven't, today we're going to build the first one together. So hopefully you'll find that interesting, and then we'll dive deeper into the challenges you can encounter with RAG systems, and a bit of how to overcome those challenges. All right. So going on, let's just start. Since everyone knows what RAG is, I'll go over this like real quick. So why do we even need RAG, which is the acronym for Retrieval Augmented Generation? RAG chatbots are essentially like ChatGPT on your own data. They allow you to utilize your knowledge base in case it wasn't part of ChatGPT's training data. If you have like private documents are not publicly available over the internet, or even if it was part of the training data, when you ask a generic question to ChatGPT, and when I say ChatGPT, it does not necessarily have to be ChatGPT, it's really any LLM, then it will not necessarily, like when you ask a generic question like, how do I transfer money, right? It will provide a generic answer. And if you're building an application for a certain bank, then when someone asks, how do I transfer money? It's important to answer based on this specific bank's application, instruction, user manual, whatever. So it has to be specific to the bank. And RAG is a framework that allows you to do that. So it's extremely useful for use cases. We have a lot of enterprise documents, support knowledge bases, product documentation, insurance underwriting docs, etc. Okay, so we know why we need RAGs. And again, cover this real quick, the core principle. So basically, the idea that sits behind RAG is to enrich the prompt when you send a question to ChatGPT, enrich the prompt with the source for the answer to the question when you ask a question. For example, if I was going to ask, who's the richest man in the world? Instead of asking this question directly to ChatGPT, I will ask, who's the richest man in the world based on the following article, and then add the Forbes 100 richest people for 2024. All right, so the core principle, just add the source for the answer as part of the prompt that goes to ChatGPT. Oh, by the way, I didn't say that, but this will be much more, I think, fun and useful if it will be interactive. So feel free to ask questions in the chat. I'm going to take a look at that. We also have the Q&A. I don't know if it works, but wherever is comfortable for you, both of them are open for me. So if there are any questions, feel free to ask. All right. So we know the core principle. Let's talk about the basic architecture a bit. Again, I'm going over these relatively quick because based on your knowledge, it seems like most of you are familiar with this. Yeah, so our end goal in the RAG architecture is to enrich the LLM with the source for the answer to the question that we're trying to address right now using the LLM. So let's say someone asks, do you support one-day delivery? And I want to find an article that talks about one-day delivery in Amazon. I'm assuming I have an Amazon chatbot, right? So I'm trying to enrich the prompt with a relevant article. And the way we do it is we use a retrieval system. And this retrieval system is based on some very cool technology called embedding models. So embedding models are essentially models that were trained for taking natural language, question like, do you support one-day delivery? And representing it in a numeric manner, right? So this list of numbers is essentially a vector representation. Vectors are like the mathematical object of vectors. This list of numbers is essentially a representation of this sentence. So what we do is we take all of our knowledge base, all of our articles that we want the LM to be familiar with or to be able to answer based on, and we chunk them into smaller pieces and store them, convert them. Instead of storing them, their text representation, we take that numeric representation and store it in a database that's called a vector database. Now, the interesting thing about those embedding models is that they are supposed to yield vectors that are close in the embedding space or the vector space in case that the text that, or like the text that was used to generate this vector have similar semantic meaning. So if I take this sentence, do you support one-day delivery? And the sentence, is one-day delivery supported? Both of them have similar semantic meaning, right? These are similar sentences. So ideally, my embedding model would turn both of them into vectors that are close in the vector space. That means that the distance, it's a mathematical calculation, but their distance is close in the embedding space. So they will generate two similar lists of numbers. And we use this in order to search that database. So when a user essentially asks a question, we take that question, we convert it into a vector using the embedding model. And then we use this vector and search for similar vectors in our database. The database that we created that is essentially vector representations of pieces of knowledge from our knowledge base. And we find the most similar or the closest vectors in the embedding space, which, again, if all worked well, correlate to the most relevant documents, which are the documents we will eventually use in the prompt. Is this clear so far? Any questions about this? Because this is like the very basic architecture, and we're going to build on top of that. Give you guys a second. Okay, cool. I see a question here. I think you can see it, so I'll read it out. So for finding relevant documents, is it always the distance, L2, or can we use angle, cosine between the vectors too? It's not always distance. It can be whatever, like you can use whichever metric works better. Usually this type of decision is abstracted from you. And it depends on the embedding model, which of those two similarity methods would work better. Usually for OpenAI, you use cosine similarity indeed instead of distance. Distance is something that's easier to use to explain, but usually we use cosine similarity. And the second question is how to convert text into a vector. So we're going to see that. We're actually going to see that in an example, like code example. Essentially, LLM providers expose an additional API that's called an embedding API that you can send pretty much text, like just send raw text, and you'll get, in response, you'll get the vector. Okay, so I see two more questions. Can we implement RAG for numeric data other than text data? Yes, obviously, yes. So the question, like, that's a very good question, and the answer is definitely yes. RAG does not have to be for textual data. This is the most common architecture, but you can also just search a regular database without going through embeddings and going through all of that. If you have structured data, you can always search a regular database and enrich the prompt with your structured data. That definitely works. That also qualifies as a RAG system. When people say RAG, they usually refer to article enriched use cases, which is what we're describing here, but you could definitely do the same with structured data. And then the last question I see is, how are relationship between text entities represented in the vector database? So that's a good question. Essentially, in the database, what you'll have are records that look somewhere like something like this. Let me say this in a second. So you'll find a record that is essentially a numeric vector, and this vector will have a sort of a pointer to the original text. That's how it's stored in the database. Now, the correlation between them is not necessarily stored. So the relationship between different texts are not necessarily stored within the vector database. That's sort of an add-on feature that can allow you to extract better results. But the very basic vector database essentially holds a list of these vectors and pointers to the original text that were used to generate these vectors. That's all that's stored in the most basic form of a vector database. Okay, see another question. I'm going to continue a little bit and then answer that one. Actually, I see three more questions. So let's do 1 more minute of answering and then I'll keep going. Isn't RAG already built in ChatGPT? So no, it's not already built in ChatGPT. There are some frameworks that allow you to use a pre-built RAG system, but essentially the very core basic of RAG is that you enrich ChatGPT with your own knowledge and your own constitution. And ChatGPT doesn't have that capability. When different encoding schema is applied to a document, how is it going to affect the search results? Please give examples of various encoding. commentary impact. Okay, I'll address this one a bit later. Will unstructured versus structured data make a difference in the accuracy and convergence of responses? Which is better? Okay, so this is a very good question. It really depends on the use case. If you have the ability to enrich the LLM with structured data, a lot of the time it will yield much better results. The reason is that your search can be much more tuned towards the result that you're trying to get. I think we will explain, we'll touch about the difficulties of retrieval systems moving forward. And I think that's when I'll pretty much address the two other questions that were asked. So I'll just go forward and my colleagues here will remind me to answer your questions afterwards. All right. So one follow-up question that you guys did not ask, but we usually see is what do you do with follow-up questions, right? Because let's imagine a chat history that looks as follows, right? The user asks, do you support one-day delivery? The chatbot says, one-day delivery is supported for Prime members. And then the user asks, what if I'm not a Prime member? If I take this question as a standalone question, and I try to search that through my database, it will probably not yield great results, right? Because it doesn't understand that I'm actually talking about one-day delivery for Prime members. So the documents that will be retrieved will probably not be relevant. There are many other ways to tackle this problem, but the easiest and simplest to understand is you send the chat history, right, this entire history, and a new user question to an LLM to generate a standalone question that takes the history as the context. So instead of searching my database for what if I'm not a Prime member, I will send this question to an LLM, and eventually the LLM will ideally return something along the lines of, is one-day delivery supported for non-Amazon Prime members? And that is a question that I can search my RAG database for, so my vector database. And this is just a funny notion of how to handle follow-up questions. Of course, there are other ways to handle this, but this is the simplest and easiest to understand. I see another question about diagrams in the documents, images. This is actually one of the struggles. We'll touch that going forward. And using Llama vs OpenAI assistants for embedding information. Okay, actually, we're going to talk about frameworks right now. So any questions related to how we handle follow-up questions? Give you guys a second. Okay. So let me just clear out all my drawings right here. All right. So Dom, I see your question about frameworks. This is what we're going to discuss next. We talked a little bit about how do we, what is the architecture? What is the, theoretically, what is behind RAG? And now we're going to talk about, well, our next phase will be to actually implement one. But in order to do so, instead of, building everything on our own, we're developers. If there's anything that we know how to do well is to use frameworks and use other people's work. And obviously there is a framework already existing for RAG. So I'm just going to present a few frameworks available. So the first one is LangChain. I think it's the most commonly used framework available for really any LLM-related application. So it's pretty much like a Swiss Army knife for anything related to LLMs. And just opening the chat, sorry. LangChain is, again, most commonly used. It's pretty much Swiss Army knife. It's great for any type of LLM application. It allows you to chain multiple tools, which we'll talk about, and components. It's implemented both in Python and TypeScript, which makes it quite easy or good for usage in web-based applications as well. And let's go over this code real quick. This is an example code. It's a pseudocode. This will not actually run, but this should give you the notion of how to implement a RAG chatbot in LangChain, and we will also be going over like real code that actually runs, and I'll post that after the webinar, so you all have access to that. But let's go over the pseudocode real quick. So we have our list of documents here. The first step we do is we instantiate a vector database, and we instantiate it from the documents that we have, and we ask about how do we take the text and convert them to vectors. So in this case, we use OpenAI embedding model, and this is all it takes to use that embedding model in LangChain. And now that we have a vector store, it's loaded all our documents, chunked them into pieces, and converted them into embeddings, we need to define the inputs that we're going to send to the LLM. So that's the next step. Basically, the question and chat history are not really relevant for this. What's interesting is the context. The context is the text or the knowledge we're eventually going to send to the LLM to try and generate the answer to the question that we have. The question is the user's question. Chat history is chat history. So in order to generate the context again, eventually is the source of truth that we're going to send to the LLM. We take the search query. Now, the search query, you don't see it here, but it's actually a query that we generated using the question and the chat history, as we mentioned, with like the follow-up questions approach. We pass it to the retriever. The retriever is the vector store here. So this is pretty much the same thing. And we eventually need to combine the documents. This is like string formatting, like appending new lines to the documents. And then eventually we take the chain, we define a chain, which basically takes the inputs that we defined here, format them into the prompt, send that to OpenAI, and then return the output. These pipes that you see here are a format that supports a syntax that's supported by LangChain that helps that yields like string formatting. And I see a lot of questions. Let me take a look. Okay, nothing new around it except for the framework. So let's go on to the next one. All right, so the next framework that I'm going to talk about is Embed Chain. Embed Chain is honestly awesome. Like Embed Chain is the easiest framework to use when you're prototyping RAG-based applications. It requires the least amount of friction to get started. It's only implemented in Python though. It's built on top of LangChain, so it's actually like an abstract layer on top of LangChain. And well, the previous code was pseudocode. This is code that would actually run. So, and we're going to show that in a few minutes, but this is all it takes today to build a RAG chatbot. We instantiate an app, and the moment that we add files, it actually creates a vector database behind the scenes and chunks the knowledge or the documents that we're about to add into smaller pieces, embeds them, adds them to the vector store, basically takes all of those steps for you. What we had to do quite manually with LangChain, this happens in a single click of a button. And of course, you know, with great power comes great, like there's no like only pros and only cons. This abstracts a lot of the detailed implementation details away from us, but this also gives us less control over our application, which is why Embed Chain usually is used mainly for prototyping, but I haven't seen being as much used in production use cases. Next is Llama Index. So Llama Index is sort of like in between. If embedding was highly specified for RAGs and LangChain is like your Swiss Army tool, Llama Index is more geared towards RAGs than LangChain, but it doesn't abstract as much of the capabilities away from you as embedding does. It is implemented in Python and TypeScript. And let me just highlight the code. Let's go over the code real quick, and we'll also like actually write code in a few minutes, so you can see it live. But the vector store, we instantiated pretty much the same idea. We send the docs. We'll use OpenAI embeddings in this case. What's interesting here is that we define what's called a tool for the vector DB, and that's actually something I'm going to touch on the next slide. It's sort of a best practice to implementing really any LLM-based application. And lastly, we generate an OpenAI agent from the tool and just asking a question, like, do you support one literally? So that's pretty much the differences between the three frameworks. We will use embedding when I show you this because it's really easy to understand. And also we'll go over an example using LangChain. And now let's talk about a very interesting best practice that is to use tools. I think the best way to understand, like, you'll probably hear the term tools, AI agents, and you probably hear other terms for this, for lack of better word, design pattern. I know it's an overstatement to call this a design pattern, but again, I don't have a better term for that. So using tools is a paradigm that we can use when building AI agents to significantly improve the results. And I think the best way to explain what using tools actually mean is to take an example of a support representative in a call center. Let's say we have a support representative in a call center for an internet provider, and a customer calls up the support rep and asking a question. And the support rep does not know the answer to that question by heart. What can the support rep, in this case, do? I'll give one example, and why don't we use the chat to just throw other examples of what the support rep can do. One example is they usually have like a call log. So it's essentially a FAQ, a large FAQ for the call, so he can open up this document and start searching for similar cases to what the customer asked. So he has access to the call log. Another thing that he can take is, or another action that he can take is usually they have like some sort of database where they can search information about the client. Like if the customer asked, why was my bill so high? They can usually open the billing information for that customer and see the exact billing statement. Why was he charged an extra $5 this month? So other than these two, can feel free to use the chat. Give me just a few more examples of what a support agent can do when a user asks him a question, a customer asks him a question, he needs to get some information in order to be able to assist the customer. All right, yeah. So, so this is a good example using, referring him to, so escalating it to a manager is something that he can do, right? He can escalate it to a manager. He can just ask his friend that sits nearby. That's another good example. Again, just going over the example of a service provider, they can probably search if there is any outage in your area or other customers in the same building have the same issue, so they have a tool for that. And essentially, we can think about all these actions that the support representative can take in order to answer or find a way to better assist the customer as different tools that the support rep can utilize to assist the customer. And we want to take the same notion and apply it to the LLM applications and LLM agents. We basically equip the LLMs with different tools that they can utilize to find answers or assist the customers when they ask questions. Searching the knowledge base, right, which is the knowledge retriever that we talked about, can be one of those tools. We can also query a database, right? Again, customer asks something along the lines of, why was my bill so high this month? No information in the database or in the knowledge base will be able to determine why is this bill so high. We need access to its bill, so we can search the data. So if the LLM knows it has access to the data, well, can utilize a tool that gives him queries over the database, he can find that information. We can check for service outage in the area. So basically, we equip the LLM with different tools to help support the customer. And this sort of design pattern is actually something that's supported by all of these frameworks that we talked about. And it's actually supported directly by OpenAI. So they've pretty much fine-tuned their models to get a parameter called tools. And if they do get the parameter called tools, the LLM is fine-tuned in order to be able to determine which tool is the best tool to be used to address the customer's current query. So if someone asks, hey, how are you today? There's no need to use any tool, so it will just reply. If someone asks, how do I reset my password? It will use the knowledge retrieval tool. And this is one, again, sort of design pattern that really helps improve the results of RAG-based systems. And it's actually one of the most commonly used patterns right now. And I think it's a good place to sort of stop and take a look at the questions and ask if you have any more questions about the tools before we jump into implementation. So I see a remark saying that we can also use Chain API to do something for the customer, e.g. their account is disabled, we send them a password reset email. Yes, definitely. You can also take actions in their behalf, and you can also chain the tools. You're correctly correct, like you're 100% correct. For example, let's say I want to transfer money. One of my tools would be in function, a REST API that allows the LLM to transfer money on the customer's behalf. And then another tool is to search my contacts. So if I as a user write something like, I want to transfer $50 to my friend James, it will search my contacts, find James, and then activate the second tool, which is calling the transfer money tool in order to transfer the money. So yes, we can also chain tools. That's a very good comment. If your support database is made up predominantly of documents, what is your view on the best chunking strategy before you even get to embeddings? Okay, so we will touch this. This is a very good question, Dom, and we will touch this a bit on the challenges piece. Usually, the chunking, for the chunking, it's a bit of a play with it and see what works best for you, given the context window that you have in your LLM, given the size of your, it depends on your documents. But what can really help in such cases is to include some metadata about which file it is, which page it is, what is the header of this page, etc. And you can use this metadata to later on filter out results. And we'll touch that a bit later on. And I see a question about how to implement a RAG system. We're going to do that in a second. Another question, when to prefer llama index over LangChain? That's a great question. To me, if you're building a RAG system, I would use, right now, I would use llama index. I feel that LangChain is a bit bloated for a very specific use case. If my use case is not so trivial and requires quite a lot of customization and a lot of different tools I want to chain, I may end up using LangChain. This is my recommendation. But honestly, I usually, if like my use case requires quite a lot of customization, I would use OpenAI directly. All right, so let's go on. Last step before we implement a RAG system is we have the chat. We just need some UI on top of it, right? That's like we need some way for the user to be able to access this, our very cool RAG chatbot. So when you prototype or when you start building your chatbots, the easiest way to start is chainlit. It's actually 3 lines of code to build a very cool, neat UI. Like this is my personal preference on the way to prototype an application. And for internal apps, when you develop internal apps, my recommendation is to, instead of building some UI or trying to get users to access it, just write a Slack or Microsoft Teams chatbot. And that really helps with user adoption because users are already inside Slack, they're already inside Teams in organization, and it's much easier for them to just send a message to the bot than to open a web page, start. It takes much more traction. Last piece is to consider writing some custom UI. Not really important right now, so let's just cover it. This is Chainlit, and we're going to see it live in a second. All right. So now I'm going to open up the code and start building a RAG chatbot with you. I see a question that says how to lower response times in RAG. We'll touch that in a second, but most of it has to do with, obviously, the size of the output and the element that you actually use. So we'll touch it in a second. All right. So let me just reshare my screen and get to actually writing some code. Right. So you should be able to see my entire screen right now. And we're going to build our very first RAG chatbot. I'm going to start with IPython because I love IPython. And we're going to start with embed chain, right? We saw the code earlier. Let me just go over there real quick. So that was the code that we had for adding LangChain, creating a RAG chatbot using embed chain. So all I really have to do is import embed chain. That's going to take a second to load. Right. Instantiate an application like you saw in the code, and then add a document. And this is actually a document that I downloaded just earlier. Let me actually show you this document. It is like the mobile user manual, like mobile application user manual for the Central Bank of Houston. The first one that I found, I typed user manual for bank application. As you can see, it has like 110 pages filled with text and images. And it's a very good example of the type of documents that we will need to have in our application. So I'm going to add it. And what we'll see right now is that embed chain will instantiate a Chroma DB. That's our vector DB for this case. What you don't see behind the scenes is that it chunks the document it converts all of those little chunks into embeddings and then stores them in the Chroma database. So really, with one click of a button, it did all these steps for us. So we don't really have to worry about the chunking strategy, etc. Again, just for prototyping. For a real use case, you may want to intervene with that. But just for the prototyping, we don't really have to worry about that. And now that we have this, let's bring it so it will be a bit prettier. I can start asking questions. So in this case, I'm going to ask, how do I deposit a check? Please be very detailed. So what will happen now is we get a response that said to deposit a check using mobile banking. You can follow the steps, navigate the transaction section, select deposit a check, choose the account you want to deposit to, capture images, etc. But this seems like a very good reply, right? Let's check if it's specific to our document. Let's see that it is actually a RAG document. So let's see. Deposit check. Okay. Deposit a check using quick actions. This is, let's see the transactions. In the navigation menu, tap transactions, deposit check. Navigate transaction section, select deposit check. Okay, that's good. On the check page, do the following: the account, enter the check number, yeah, etc., etc. Tap capture image. Pretty much the same steps that we had there. So yeah, so that's only took 3 lines of code, and we have pretty much a RAG system. This is how easy it is today. Of course, it's not really that easy in real life. If I start asking it more complicated questions, like, can you list all of the steps required to, let's do deposit check again. And let's piece. This is gonna take a few seconds. Okay. On the home page, tap deposit check. Yeah, we see a list of steps that seem like very legitimate. I'll tell you in advance that it actually mixed the steps between depositing a check using the transaction and depositing a check using quick action. So the steps here are a bit mixed, and you won't see it here, but it's not perfect yet, but it is our very first prototype. Anyone wants to try a different question, feel free to write in the chat or in the question and answers, and I can try it right now with you. Give you guys a second. All right. Okay. Ooh, see, we're way behind. So let's go to the next step. And let's actually add some UI on top of it. I hope you can see my screen right now. This is taking the same code that I have. I take embed chain, I instantiate an app, and I add the file. And this time I'm just adding some UI on top of it. Right? I'm just adding chainlit just to show you how easy it is to do chainlit. So now I have to run it, chainlit run .py. Take a second. Okay. So we now have UI on top of this app that we created, right? And again, we can ask questions specific to our bank, like how do I wire money? And pretty similar. So took me about 7 lines of code, and now I have an application, pretty much a RAG chatbot. Again, not a perfect one, but it works with some user interface that is honestly looks pretty good. And yeah, that's really all it takes today to write a RAG chatbot. Now I'm going to would it reply with the source of the information, e.g. which page or which section? So yeah, we can code it this way. So we can make sure it does reply. We call it citations. So we can make the chatbot use citations instead of actually replying with the exact text. Like also like reply with the answer and then put citations at the bottom. We can add that capability. Yes. Let me actually, one thing that will be interesting here is to see the prompt that eventually gets sent to OpenAI. So this is the actual prompt after we format it. So you can see that the question, this is the prompt. Let me just copy it right here. So this is the actual prompt that gets sent to OpenAI. Okay, this is what LangChain, InventChain does for you behind the scene. It says you're a POA expert, some guidelines about how to answer the question. And then this is the actual context it was retrieved. So this is the relevant documents that were retrieved in order to generate the answer to the question. And this is the user's query, how do I wire money? So basically, InventChain behind the scenes takes all of this information for you, just like we talked about, formats it all into a single prompt, and then sends that to the LLM. Okay. So let's go ahead a little bit. So we've now pretty much built our very first RAG chatbot. And I think that's awesome because it only took us, 45 minutes and 7 lines of code to build our very first RAG chatbot. I think that's pretty impressive. But now let's talk about all those questions, those difficult questions that we brought up earlier and I didn't want to discuss yet. So what are the challenges when building RAG chatbots? So I think I saw a question earlier about what do you do in case that there are graphs and images in the documents? And that's a very good question because the very first challenge when building a RAG chatbot is that the formats, or usually the knowledge base on which I'm trying to create my RAG chatbot, was built in order to be consumed by humans and not by machines, which means it will include formats that are not easily read by a machine, like PDFs, web pages. Those PDFs will include images, they will include graphs, they will include additional information that cannot be conveyed or is not easily conveyed to an LLM. And this is one of the biggest struggles that we have when building a RAG chatbot. Our knowledge base is not designed for the RAG use case. And the way to overcome this challenge is, unfortunately, to do quite a lot of manipulation. Like right now, all you saw me do is just take the document and add it to the application. But generally, you have to do a lot of preparation for your knowledge base. If you see images, you can use image-based models, like visual models, to generate an explanation of what happens in those images, and then embed this information as part of your knowledge base instead of the image. So basically, each image that you see, you replace it with actual text representation or semantic understanding of what this image represents. So that's one recommendation, and of course there are other ways to go about this, but I'll have to hurry up because we don't have a lot of time. Second piece is that, or second challenge is that retrieval is very, very hard. So it's a difficult it's a difficult task, like retrieving the relevant information in order to answer the question is a difficult task, and we'll touch a bit on why that is. And the last piece is that generation, like the LLMs themselves are quite imperfect. So we see hallucinations, we see toxic responses. There are other issues with LLMs that make it very hard to build a good RAG chain. Let's talk a bit about why retrieval is hard, but before that, I'll just take a look at a couple of the questions we wrote. If I have a confidential dog, how can I use RAG to get the knowledge from it without exposing any of the confidential data? So that's a good question, and there is like the best answer is to use an on-prem LLM instead of using OpenAI. So you have very good open source LLMs that you can run with on-prem, not necessarily in your computer, but on a GPU that you own on the cloud. Llama 3, Mistral, and other open source LLMs would be a good fit if you have confidential documents. Another question is, as context windows increase with each new foundation model, what is the relative increase in accuracy of RAG approach? That's when the support document could technically fit into the context window along with your chatbot. I.e., what is the recall or retrieval? So that's a good question, very good question, Dom. So honestly, it's the context size does increase, but like there are many research papers about how LLMs really have very good attention to the start of the prompt and to the end of the prompt. And there's one that's actually called what gets lost in the middle. So the ability to recall is not without fault. So even with gigantic context sizes, it's not a good, like it doesn't work without flaws. But of course, retrieval is also hard. So usually what's recommended is to use, to sort of do like a hybrid approach. You still need a retrieval, but you can maybe do a retrieval that is just like topic-based retrieval or use much larger window sizes, etc. But generally speaking, in most knowledge bases, you will have data that actually conflicts with one another. And again, that will make the ability for the LLM, even if you provide all the information that you have in the context or in the prompt, it will make the LLM's answer be not necessarily the best. So you have to do a lot of work preparing your knowledge base. And usually you do need some level of retrieval. It can be just topic-based retrieval, it can be even a bit more advanced, but don't just throw your entire document set at ChatGPT. It will not work well. Okay, so I see another questions. Okay, we have 5 minutes. I can stay a little extra. I don't mind extending. So I will stop answering the questions right now. I will go to the just go through a couple of more slides, and then I'll stay on to answer questions as much as you'd like. I have like an extra 15 minutes. All right. So let's talk a bit about why retrieval is hard. Retrieval is hard because we base our solution on on an underlying notion that vectors or text with similar semantic meaning will yield vectors that are closed in the embedding space. And this is just a representation. like a 2D representation of those vectors. So we can see that for tech reviews are closer in the embedding space to tech productivity videos than they are to medical education, right? That makes sense. So that is like the underlying notion. And again, if I take the sentence, how can I analyze large data sets, and the sentence, how do I process very big data? They have very similar semantic meaning. So the distance will be low. But if I take the question, how can I analyze large data sets? And the answer, you can use Snowflake for efficient large-scale data processing, yada, yada, yada. Those two sentences have very different semantic meaning. So the distance between them is likely to be hard. The distance between the question and the answer is not likely to be small because they have different semantic meanings, right? So just because two text chunks are close in a bank space does not mean they match as question and answer. And this is a very important thing to understand because this is usually what happens when you have issues in your retrieval. You don't retrieve the relevant information in order to answer the question because it's not necessarily the most semantically similar information. I hope that was clear. So a couple of solutions for the retrieval, or a couple of ways to improve your retrieval, fine-tuning the embeddings. I actually don't think we have time to go into that, so I'll skip this one. Other potential solutions for retrieval is to fine-tune neural search models. We have a technique called hide, which is interesting. So actually, because it is a very interesting technique. So basically, we use an LLM to generate a generic answer to the questions that the user is asking. And then we convert that generic answer to embeddings, and we search that generic answer in our database with the underlying idea that the questions or the answers to the questions are likely to be similar, even though one is a generic answer and one is an answer that is specific to our constitution and our knowledge, it is likely to be quite similar. So that is actually a technique that works quite well. Reverse hide is the same idea, but the other way around. So we fake the question and we embed questions in our database. Potential solutions for like another couple of solutions. We can use two-stage retrieval. So retrieve a lot of documents and then we rank them using an LLM. We filter out the metadata, which we talked about. So someone asked a question about what do you do when you have, like, what is that chunking strategy? So as I laid out, chunking strategies, I don't think it's as important as other capabilities like filtering out based on metadata. So if a document that is retrieved for answering the how do I deposit a check question is retrieved out of the section, the like out of a page with a section called depositing a check, it's really relevant. But if it was retrieved from a section called general FAQs, or no, actually general FAQs is a good one, but from a section called wiring money, it may be less relevant. And this means that I can filter out this document. So if you, when you store the documents in the database, you store them with additional information, like what section out of your knowledge base were they taken from, etc., you can really get much better results. And lastly, there's knowledge graphs. Again, we don't have time, so I'm not going to go into that. And I'm sorry that I'm a bit rushing towards the end here. And lastly, we talked about this fact that generation is imperfect. So the LLMs tend to hallucinate. They tend to have toxic responses. the way to mitigate those issues is using prompt engineering, but that is quite limited. So like that won't get you a solution that will improve your results. Second thing that we can do is fine-tune the LLM. Again, this will not prevent 100% of your occurrences. This will slightly improve the results as well. And lastly, guardrails, I think, is the most recommended way to reduce issues with the generation. So toxicity issues, hallucinations, etc. The idea behind guardrails is to use third-party observer to determine if the answer is good enough or not. And this actually works. Out of the three options, this works. This has shown the best results when applied in a real production use case. And thank you. Okay, so this was it. I'm sorry that I rushed a bit towards the end. I just thought it would be good for you to get the even if it's just like topic level, get the idea of what are the challenges and how to mitigate those challenges in RAG applications. And I'll now stay an extra like 15 minutes to address all the questions that we didn't have time to before. And thank you very much, all of you, for listening. It was you brought up some very, very interesting questions, and you were a very attentive audience, so thank you all. And if you ever want to reach out, either to me personally or to Aporia, we'll be happy to chat, to show you around our product, or just chat in general about RAG applications and LLM. Feel free to add me on LinkedIn. Feel free to visit the Aporia webpage, and we're there to accommodate your every need. So I will stay a few more minutes just to answer some questions. Let's see. Those that I've missed. So I see question, how do you specify in the simplest framework to speed out the original document in RAG search result? Okay. This is like something that is part of the like it would be, this is why I wouldn't use bedchain for this use case. I would actually use LangChain. And in LangChain, I will get the documents. So let's actually present the code. Let's go over the code. I have an example here that uses LangChain. So when you do the retrieval part, you can actually store the documents that were retrieved and also display them in your UI, right? Instead of just replying with the message that your LLM generated, you can also add, instead of just a response, I'll do something like this, plus last \n, original documents, and then link them. It is a bit harder to accomplish with embed chain because embed chain abstracts all of this away from you, but you can do that with embed chain as well. Dom, to your question, so I see you ask about RAG hallucination. Let me actually show you that live right now. So Dom asked about the Aporia RAG hallucination guard. So I have an example here with another application that uses streaming and is also connected to Aporia. So it basically uses Aporia is not an LLM, it's just a guardrails provider. We use OpenAI for this LLM, but it is also connected to the Aporia guardrails solution. And let's actually run this code instead right now. Okay. So now what happens when I ask a question? It actually also validates the response using the Aporia system. Whenever I ask a question, the question also gets validated throughout the process. Currently, the validation is turned off. So we have it turned off for this application. So I'm going to ask a question like, how do I dispute a transaction? It's going to take a few seconds and right. So it spit out an answer, supposedly a good answer, but this is actually an hallucination because the document that we fetched does not bring up the word dispute once. You can cancel transfers, but you cannot cancel transactions. I mean, you can cancel transactions, but you cannot, like, it doesn't allow you to dispute them. The canceled transactions are actually only transfers that you can cancel. You'll have to trust me, I'm not going to go over this 100-page document, but this is actually an hallucination. You know what? The way to see it is actually here. You can see it in the retrieve context. Again, it won't say anything about disputing or cancel, like, the activity center, browse, etc. It says about cancellation. It doesn't say anything about dispute, right? It doesn't say that you need to feel anything about dispute, the disputation, etc. So this is the document that was retrieved. And if I will turn Aporia guardrails on right now and ask the very same question, Aporia will detect this and block. And wait, takes a few seconds to actually turn on. And the way it works behind the scenes is we use a smaller language model in order to be able to do this in a timely manner. And this smaller language model should is fine-tuned for detecting hallucinations. Therefore, it will see that the document, let's give it another few seconds to turn on, but the underlying idea is that we use a smaller LLM that was fine-tuned for the purpose of finding hallucinations to verify the answer against the context, so the document that was retrieved. And using that, we can determine in real time if this is an hallucination or not. Let me check why this is actually working. No, okay, so it should actually. Yeah, okay. So now it's actually working. The idea is that Aporia, again, in real time, it checks if the answer that was generated by the LLM is completely adherent and can be entirely deduced in its entirety from the context it was retrieved. And if not, it is deemed as an hallucination. Let's see a few more questions. So how do you ensure / evaluate that the search result is aligned with the ground truth? So the search truth is what I would consider, like the search result, like my knowledge base, is something that I would consider as the knowledge base. It's usually something we consider as the base of the truth, right? We trust the LLM's data less than we trust our knowledge base. Our knowledge base is our own curated data. It was designed like it's our own documentation. They may be a bit older, but they have to be accurate. And we want the results or the responses to be based on those documents. So we don't need to evaluate the search result. What we may need to evaluate is the answer that was generated from the LLM to ensure it is aligned with, again, ground truth being the document that we retrieved. So we retrieve the documents that were retrieved, or not necessarily documents that were retrieved, but the overall knowledge base as the ground truth. Okay. I'm very curious to see what specs you have set up: LLM model, embedding model, chat temperature, etc. In this example, The LLM is GPT 3.5. It takes the embed chain defaults, which I think is temperature should be like 0.2 and top P should be 0.2, if I recall correctly. This is like the default example, and I use GPT 3.5. Again, all of the defaults by embed chain. Scales. Any more questions? Let's see, the rest of them are older questions. Any more questions from anyone? No? Okay. Thank you all for joining me. Thank you all for listening. Again, very good, great questions. Appreciate questions. And I'll stop the recording now, and feel free to hit me up on LinkedIn or on email if you have any more questions.